The North American XB-70 Valkyrie aircraft was developed for the U.S. Army as a strategic high-altitude bomber. The starting point for work on a new supersonic strategic aircraft was the proposal of the U.S. Air Force Strategic Air Commander, General Curtis LeMay, who at the end of 1954 raised the issue of creating a bomber with a range without refueling in flight of at least 11,000 kilometers at the maximum possible speed. This aircraft, suitable for operation from existing airfields, was supposed to replace the B-52 and be in service with the Air Force in 1965 to 1975. In October 1954, the terms of reference for the WS-110A weapon system were issued and a competition was announced for preliminary projects of a strategic bomber with a cruising number of M=0.9 and the maximum possible speed at maximum altitude when breaking into the airspace of a potential enemy at a distance of 1,600 to 1,850 kilometers.
Subscribe to the channel, it will be more interesting. Thank you in advance.
The history of its creation is long and I want to continue. The XB-70 was conceived as a prototype for what the USAF hoped would eventually become the B-70 nuclear-armed bomber. The XB-70 was capable of flying at altitudes up to 21 kilometers and had a top speed of an incredible Mach 3,300 kilometers per hour or Mach 3. One with a cruising speed of Mach 3.0 or 3,200 kilometers per hour. The goal was to create a bomber that could fly at Mach 3 for its entire mission and be immune to Soviet anti-aircraft missiles, as well as its fighters.
Let me clarify something. The XB-70 first took to the skies in 1964 with a successful test flight. However, as development continued until the first flight and when the aircraft was being built, a new generation of Soviet surface-to-air missiles were being developed, and by the 1960s these missiles were beginning to be used. It was hoped that the B-70 would replace the B-52 and B-58 bombers, the latter of which was a supersonic bomber. However, neither of these happened.
Of particular note are its engines. The XB-70 was powered by 6 General Electric YJ93 GE 3 turbojet engines designed to use JP6 jet fuel. The engine produced 28,000 lbf, 120 knots, with afterburner, and 19,900 lbf, 89 knots, without afterburner. The Valkyrie used the fuel to cool through heat exchangers before reaching the engines. To reduce the chance of self-ignition, nitrogen was injected into the JP6 during refueling, and a fuel pressurization and inerting system vaporized a 320 kg supply of liquid nitrogen to fill the fuel tank vent space and maintain tank pressure.
By the way, I must say who was the initiator of the creation of the aircraft. Initially, the research program was conducted through the U.S. Air Force, but in 1966 a joint program was started with NASA to help measure the intensity and nature of sonic booms. Meanwhile, the data used in the earlier program will eventually be used in aircraft such as the State Route 71 Blackbird, the B-1 bomber and the Tu-144 supersonic airliner.
I want to talk about the fate of 2 prototypes. The 2 XB-70s were slightly different, and the second aircraft solved most of the problems found in the first aircraft, which could only fly at Mach 2.5. However, things soon went awry. During a photo shoot hosted by General Electric, the second of 2 XB-70s was lost in a fatal collision with an F-104 fighter jet. The fighter was pulled into the Valkyrie's structure, rolled over the vertical stabilizers, and damaged its left wing before catching fire, with pilot Joe Walker unable to survive. The XB-70 flew straight for 16 seconds or so before spinning out of control. Co-pilot Carl Cross also failed to survive, and pilot Al White ejected but was seriously injured by an innovative escape pod fitted to airplane.
It is necessary to tell about the main parameters of the aircraft. Plane scheme: duck with a thin delta wing and 2-keel vertical tail. At a speed of m equals 3, the temperature of the skin could reach 330 degrees Celsius, and stainless steel Rn15-7MO was widely used in the design. High-strength tool steel H11 titanium alloys, stainless steel Am35 and nickel-based alloy Rene 41 were also used. These materials retain high strength in the calculated operating temperature range V70, equal to 230 to 330 degrees. Developer North American. Designation XB-70. NATO codename Valkyrie. Type supersonic strategic bomber. Crew, hearse. 4.2. Geometric and mass characteristics. Aircraft length, 57. 61 m. Aircraft height, 9. 14 m. Wingspan, 32 m. Wing area, 585.07 square meters. Wing sweep angle along the leading edge 65.57 degrees. Along the line 1/4 chords 58.79 degrees. Specific load on the wing, 410 kilograms per square meter. Takeoff weight, maximum design 251.5 tons. Typical actual 236 tons. Normal landing weight, tons 143. Construction weight, more than 58 tons. Full fuel supply, more than 138 tons. Power point. Number of engines 6. Engine TRDF GE-XY 93, YJ93 GE3. Engine thrust, KGF, KN, maximum 11350, 111. 3 kg force kilonewton. Afterburner 14,060, 137. 9 kg force kilonewton. Flight data. Maximum flight speed at altitude, 3,218 km/h. Cruise speed, Mach 1. 52. Takeoff speed, 350 km per hour. Landing speed, 335 km per hour. Practical ceiling, more than 21 km. Maximum range, estimated, 12,000 km. Turning radius at m equals 3, not less than 160 km. Time to perform a 180-degree turn with a bank of 20 degrees, minutes 13.
Let's wrap up this project. It was hoped that the research still associated with the Valkyrie could be completed with the first aircraft, but its performance was not up to the required level. The last flight of the XB-70 took place on February 4, 1969, when a Valkyrie AV-1, serial number 62-0001, took off for the National Museum of the United States Air Force at Wright-Patterson AFB near Dayton, Ohio. It has since become the pride of the collection and serves as a constant reminder of one of the craziest aircraft designs ever created. One of the few aircraft ever built that had the potential and capability to reach Mach 3, and a tribute to those test pilots who died.
Don't forget to subscribe and like.